All right. Well, everybody, all six, including us, but we'll see how it goes. My name is Kevin Galligan. I'm the founding partner at a company called TouchLab. I guess nominally CTO, although at some point we'll get that on the business card. Been doing Android since G1, before G1 technically, and was generally involved in the community. Hold on, focus. TouchLab is a mostly mobile dev shop. We have in the last few years pretty much just changed everything to focus on KMM and KMP. So it's pretty much all we do. And we've had the good fortune to have some great partners out of the gate, working on really cool stuff. A lot of this partnership has been going on for a few years now, and a lot of it's developer experience and quality of life stuff for people doing KMM. So it's been pretty great. This talk is kind of a copy paste from the 2019 talk, which was a copy paste to the 2018 talk with updates. So you get this opportunity to go through and see what's changed, to go down memory lane, and what's like timeless advice and things that you're going to keep around, and then stuff that you are going to throw out, and bad ideas and things that no longer exist. So we'll kind of dance around both of those things and call out to it here and there where it's interesting or whatever. So as a basic intro, libraries are crucial for any successful software ecosystem. I think that's a pretty simple statement to make. I call back to this blog post from the Dropbox engineer, who is essentially saying that shared code has got a lot of costs. I would say that this is a little broad. It's more about why C++ is a bad option. But there are things to take away from this, and I'll talk about it in a second. I have this quote, and it's a shared UI is a history of pain and failure, and shared logic is a history of computers. I meant this more in the context of like all-in-one cross-platform stuff, right? Because with Compose coming to other platforms, it might be interesting. We'll see how that goes. But focus on the second part of the statement, which is shared logic is the history of computers, and certainly shared libraries, quality shared library, and the shared library ecosystem is a great way to increase that efficiency and multiply force there from that. And then somebody screen quoted Russell talking, Alan Shapiro quoting me, quoting that quote. So I decided to screen quote Russell quoting me, and he's probably going to quote that in the next talk. So anyway, this came from the Dropbox post, and this really stuck out for this talk. And the easiest thing to predict about the C++ problem is the need for build frameworks and libraries. It's then essentially saying that these things didn't exist in any meaningful way. They need to build a lot of stuff on their own. And of course, it's going to be terrible, and why you need the ecosystem. And KMP is really no exception, and even more so. Because KMP is very lean. You don't really know where common Kotlin's going to run, right? It could be on the server and JavaScript, mobile clients, IoT hardware, anywhere. So these things that you would normally just assume to exist do not. And they need to be created by libraries and added to the ecosystem externally, right? So it's a big hill to climb. However, there is a very vibrant and active Kotlin ecosystem. So, so there's lots of stuff out there. I got like a risk notification that kind of threw me off. So why consider KMP? And I really should have context this slide a bit more. Why consider KMP to do open source library work in? And I would say, first of all, there's lots of interest. And this is a picture from the 2018 talk I gave about libraries and stuff. And even then, the room was way more packed than I expected. And that interest has only grown significantly since then. And, this was from last year's talk. I was so excited about the 2020 and 2019, what an innocent time. But even with the thing that happened, certainly this has been true. The growth of KMP adoption has been significant. And if you go check out this page, it's very interesting. You have the case studies, and you can see scroll, and the people doing KMP stuff in production. And you'll find a little blurb about us in there too. I wrote this blog post recently, and I wanted to highlight Kotlin 153, which would probably seem as a rather quotidian release, just a point release, but in fact, there were a bunch of things in there in preview or in maturation that I think is going to signal a meaningful inflection point, and that is KMP KSP is coming, or is it sort of matured, along with compiler plugins, it really kind of to a point where you can use them, although not entirely publisher stable, but certainly usable. Hierarchical source sets have been improved significantly, and more specifically in 1.5.3.1, I think that they're actually sort of ready for prime time, especially for complex library production. That's for tooling and very important. And then most importantly, the new memory model is in preview. And if you don't know what that is, then this may not be the talk for you, because it's sort of a Kotlin multi-platform issue. And Native has this unique memory model. And the last few years of my life have been trying to explain it in order to get people to understand it and use it. And I didn't think it was that bad, but here we are, we're changing it. And this is, I guess, in a lot of people's minds, one of the last building blockers to adoption. And we'll see how that goes, but that's happening now. And it's an interesting time. I will throw in a very personal and adamant request from the Native team, which is now they have it in preview, please go try it. Because the only way we're going to get really significant bugs and fixes to this native memory model is to have people go give it a shot. So please go do that and report bugs as they appear. So I say this in all my talks about libraries for KMP. It's a great time to get in because it's relatively early. There's a lot of space for libraries to be built and published, especially around architecture and as composed and Swift UI and other things are coming in. There's a lot of space to do some good work. And if you want to be an open source library producer, now is a great time because you can get a lot of traction and visibility, right? As opposed to when the ecosystem is rather crowded. So once again, calling you to make libraries. What is Kotlin multi-platform? It is a section of this talk that I almost consider taking out because if you don't know, it's probably going to be a weird talk. But let me quickly go through it. Kotlin multi-platform is essentially it's a language definition and ecosystem of compilers that allow you to write shared common Kotlin and then have that be rendered down to platform specifics, compiled and deployed, right? And these are the three commonly understood compilers. There's a fourth one now, which is really for WebAssembly, but that's sort of new, so not in here. The reality around this is there's really a lot of specific platforms, and this diagram, if I didn't make it several years ago, would be significantly larger still. And even on the JVM and JS side, the IR compiler is kind of adding another dimension to this. It's a lot of complexity to understand once you get into it, but the reality is, think of it kind of like these as the broad categories. So when you are compiling you want to compile for a particular platform, and that is how something gets realized. And the process of that will go up in the stack and include one to many layers of different source that's more specific for that platform, compile them together and produce an output. In the case of iOS, you might make an Xcode framework to then incorporate in your application. Or if you're making a library, you might make a klib and publish that in a way that other people can use. JVM, kind of similar. Maybe you make an app, or you're going to publish a library. That should be klib. I realized the slide. It's a quick balance, but whatever, you get the idea. So general library patterns, and this is sort of think about what people generally focus on in different contexts. So the simplest one is essentially you want to have some code that does a specific thing and just use it in multiple places because you don't want to write it multiple times. Think tax calculator, right? Has nothing to do with iOS or Android, has everything to do with being accurate. So that's kind of the simple thing. SDK platform wrapper. You may have very similar things in concept on different platforms that are expressed in different ways in their API design. And you can write a common Kotlin language and then delegate that to the specific platforms. This is obviously a very common usage for Kotlin multi-platform library creators. And then sort of this other niche where if you think about, let's say, on Android, if you want to do something in Kotlin, it's essentially everything because everything's available, right? It's all Kotlin accessible. If you want to do something in iOS, you need to create the adapter for that. So a concrete example would be on iOS, we publish SQLiter, which is the sort of low-level driver that sits underneath SQLite, so you can do multi-platform database operations. It's sort of a niche thing, but it's going to be a wide thing once we want to implement other layers, other things. So anyway, they're just general patterns. Many libraries will be a blend of these things, but they're sort of useful categories to think of what you might do with the platform. And then the other kind of side of this is who is the audience. I think we all obviously think of, okay, open source community license, not licenses, libraries, and we're gonna build a thing, publish it, other people can use it. That's what libraries are for. But that's the thing you mostly see. What you kind of don't see, because it's not public, and we found to be fairly large and a significantly growing section of the KMP world, and honestly makes up the bulk of our company revenue at this point, is helping larger organizations that had internal SDK building and distributing teams that build things for other parts of the org, and either directly building it with them or facilitating their kind of big build and distribution problems behind private walls. And I will take this moment to again plug us. If that's something that you are looking to do in your org, you know where to find us, I guess is the best way to say that. So that is basically what we're doing these days. So the real trick outside of just code is how to express platform specific logic in a way that weaves the platform agnostic code that you're going to be writing, right? So the first thing I think every KMP developer is exposed to, and certainly I would say a lot of the tutorials, I think, way overemphasize this, is expect actual. And I think that this gets overemphasized because it is such a unique language feature. It's built into the language and allows for this sort of platform specific agnostic communication. So essentially what it is you're saying, I expect this, and you write that in common code, and in platform specific code, you say, actually it's this, right? So as a very simple example is this val, it's is main thread. And from common code, you call that and it'll tell you, true or false. And then let's say you're in Android, you're going to do this as an implementation that will tell you whether or not you're in the main thread. And iOS, arguably simpler, unless there's an extension function I don't know about on Android, that probably is. Just query if it's main thread, tell you the same thing. And if we had a time for a trivia question, how would you do this on JavaScript? It would just be true, obviously. Anyway, that's the core concept, is being able to write a thing you expect and then have it at compile time and fail compile if you don't implement that. You've got vals, you've got functions, classes, objects, annotations, any kind of core code concept you would expect in Kotlin is going to be expressible and expect. And I'm sure that you'll be like, well, you can't do this with expect. I know, but it's a talk. Just go with me here. There's this other sort of unique thing that I point out, which is a very powerful thing you have in your toolkit, but be careful. It's an actual Typealias. And Typealias normally is just saying, I want to call this thing that thing. And it's kind of a naming thing, but in expect actual, it's a bit more powerful than that. So this is from Stately. I wrote to expect class atomic int, and here's all the things that atomic int needs to do to be an atomic int as far as Stately is concerned. And on the JVM side, it was specifically designed so I could just do this. And it just says, if you want atomic int in common code, we're going to do it with atomic integer on the JVM. I think it probably avoids a whole bunch of binary and extra stuff. It just directly swaps this thing out. And they need to match exactly, of course, right? Because otherwise it wouldn't work. And that's great. The problem, of course, then is on other platforms, let's say native, need to now create another class, and you need to have a wrapper delegate, and you need to map all those things to that, right? So it's like one platform is real clean, one platform is less clean. And we get into this concept that I started calling platform affinity, which is the thought process of designing, perhaps like either agnostic or for a specific platform. So by that, I mean, when you're designing this SDK, if you're going to lean Android, and there's a lot of arguments why you would, it might be upsetting to other platforms, but it also is it's going to introduce the least drama to the Android side. It's a long story anyway. Everything's going to look like Android, and iOS, you have to adapt it with this Android-like thing, right? And then maybe you decide to go the other way, and then you have this, and it's kind of like a way that things kind of work, especially I would say early on in the SDK development. But then you get stuff like this where you're now, especially with SDKs that involve lists of data and a bigger tree of potential objects, you wind up wrapping a lot of stuff that gets ugly, yada yada. You really kind of want this maybe in a lot of cases. And then I introduced this concept of empty type alias, and then this would take up the rest of the talk. And if you want to see that, go look at the 2019 because I decided to cut that entirely out. It is an interesting topic. I do need to revisit it. There's a lot of thoughts that have followed on in the last couple of years, but it is it goes kind of deep into the thinking of how you would granularly attack designing your SDK. So go check that out, and hopefully at some point we'll kind of revisit that concept. But I will say, clawing back from the expect actual, what you actually do a lot of the time, and I advise this to everyone, it's like the first thing I say when getting into KMP, like, don't forget interfaces. Prefer interfaces. And by that I mean interfaces in open and abstract classes, because you can, assuming they make sense in the context, you can be much more flexible. So this is Russell Wolf's multi-platform settings library. It's a really simple and straightforward example, right? Settings that you're going to use as this interface. It's not an expect actual, it's just an interface. And then on a particular platform, you're going to have this Android implementation that uses shared preferences. But who knows? Maybe you want to use the encrypted thing, whose name I forget now. It's more flexible, just an interface, no expect actual. There's a bunch of reasons. It's much easier to test. You can do whatever implementation you want there, that kind of stuff. So all that to say, don't overdo expect actual in the beginning, because you're going to spend the next few months ripping it back out. I think everyone's first KMP thing is that. And then a sort of subtle side note, because I think of them differently, but they're really kind of the same thing. The same thing is like function args are like essentially a single function interface, and it's all kind of the same stuff. So rather than some kind of expect function, you can just have a function arg with a type and replace that kind of thing. I used to say minimize expect actual, like the DroidCon 2021 app actually has 3 expect statements in the entirety of the thing. I kind of caveat that now, especially because I publish a library and say, don't use expect actual. And people look at it like, you have expect actual kind of all over the place. And I'm like, well, all right, true. You kind of have to learn where these things are best put and use them intentionally and understand why, right? So in our soon to be discussed logging library, we have this abstract class LogWriter. And then on the Android side, we've got LogCatWriter, which seems like an obvious choice, right? And you might start out with an expect LogWriter class and an actual LogWriter class, but that's terrible, because then the only thing you could ever do is LogWriter on Android. Testing, it's a nightmare. Like, you can't do any of that stuff. So it's obvious once you get into it. But then at the same time, we have a convenience function in the shared code that pulls a default platform LogWriter. The reason is because every time you use this library, you'd have to then create a special source set for each platform just to initialize the LogWriter if you didn't need it otherwise. So we could avoid that with that, but it's optional. So anyway, which to use, I would say pretty much interface, abstract open classes, not even wherever reasonable, wherever you can't find a good reason not to is kind of the answer for that one. Singletons, service objects for sure, easier to test. That whole Typealias platform affinity thing, and really kind of depends on what you're doing. And then expect actual, like, I don't really have a good set of hard and fast rules. There probably are if we did a survey of, like, let's say our code and other people's code, like where are good places and where not. And it's probably a whole separate talk, but you get a feel for it, or you'll get feedback in your library telling you why it's a horrible idea. So either way, you'll kind of learn it as you go. And then this slide is really more of a note for me to go back and research this. That whole like delegate hierarchy thing. At the time, inline classes is a possible solution to that too. But at the time I wrote that talk was really the last time I did a deep dive, and these were much more experimental at that time. So something to look into if you're out of other options. So platform interop. So the expect actual, the interfaces, all that stuff's great if these things exist on the different platforms, but you need to find a way to access them. But there's a lot of cases where things obviously don't exist at all. So in Kotlin Native, there is Cinterop, and Cinterop is instrumental in most of how the platform operates. And at its very basic, what you do is you tell Cinterop, this native box is Kotlin Native compile. You tell it that there's a header over here and I want to use, and then Cinterop is very good at just taking that header and creating like Kotlin calls that you can access and directly access that C code, right? And in this perfect world, then you're going to build your app and you just need to provide the actual binary that's going to match up with that header, and then everything works and you can call it. It's all great. In the real world, and why I kind of tended to avoid Cinterop for such a long time in any grand sense where you didn't need it, Cinterop configuration becomes very complex. It's not just as simple as like pointing at a header file on disk all the time. Like maybe you have to go download the header file and you have to maintain versions, and you have to find a binary that you can compile your test against, and you have to make sure, you know, you don't do it in a way that's going to make a problem for downstream when the app wants to have a specific version of this thing, yada, yada, yada. Like it gets to be something I find to be difficult to maintain. So with a concrete example, the thing we're going to talk about later, we need to have access to Crashlytics for a few things, but the way that you today, and there's another library that's very similar to Crashlytics. I won't get into it, but they're using CocoaPods to import Crashlytics, but they're only doing it to call a couple of functions. And it just seems like it's enormously brittle and specific thing. But it does give you the header, and it does give you the binary you can run the test against and compile against. So it does solve the problem that way. But especially in cases like this, which is I found very often the case, you only need a small sliver of this larger external library. So it becomes a sort of difficult and critical thing to manage. So technical talks have a problem of recency, and this is the thing that's been on my mind for the last few weeks. So I have this thing called Truncated Headers, which I essentially took Crashlytics and the way that native compile C, C++, if you don't do that very much, if you're sort of a JVM person, like it's just telling you what's going to exist. And then you have to satisfy those things later when you link them. But you can, there's nothing stopping you from taking that humongous sprawling header file and just taking out the little things you miss. And then putting, and especially in this case, it's things that are unlikely to change with Crashlytics versions. So they're just in the source, you point at that thing, it gives you the very minimal API you need from Kotlin. And it was like this, realization and revelation. I'm like, great, Cinerop's gonna be awesome. It isn't that simple. Linker errors, so if you just run that, the Kotlin thing will start building and it'll build the Kotlin, and then it'll get to build the Kotlin test and it'll blow up with this. And if you've never seen these before, it's saying, I don't know where that thing is, essentially. What that means is you imported the header, but you have no binary that satisfies the header, right? So to explain that somewhat better, go look at SQLiter, that is the SQLite driver I was talking about earlier. In a very simple way, the way that exists is you are going to compile your Kotlin native that's going to point Cinterop at SQLite.h, which exists everywhere on the planet. It's going to ingest that and give you Kotlin callable functions you can use, right? And then in order to have the test run, we have to tell Kotlin native, hey, link with the SQLiter that's distributed on your platform, which again, SQLiter exists on every place on the planet, right? And that will satisfy the tests. And then when you go to build your app, you just tell your app, get SQLite from the device you're on, and that'll also satisfy the runtime requirements, right? And it's kind of neat because you can also do things like this, where you can just say, actually use SQLcipher, which is a binary compatible representation of SQLite at runtime. So that's kind of how that works. It's all nice and neat. It becomes much more of a problem when you're like, great, I have Crashlytics, the header. Where do I get Crashlytics, the humongous thing? And how do I get that to satisfy just the tests? And what happens if the downstream app is a different version and kind of stuff. So testing Cinterop can be tough, as discussed. So it's something that you have to be aware of and tread lightly into. Cinterop can be complicated. Better tooling hopefully will improve this. We'll hopefully get there in time a little bit later in this talk about things that we're working on to improve that tooling. And I threw this in there as didn't know where else to put it, but as an alternate to this, in many cases, the effort to incorporate Cinterop to talk to some native thing is simply not worth it. And maybe putting a little extra effort on the user of your library is worth the lack of complexity and whatever. So a concrete example is logging APIs. Almost all of them are a string that's a name and then a bunch of values that's a map, and that's the entirety of it. So to create modules and to talk to direct logging APIs analytics APIs through Cinterop is an enormous amount of work versus just having a very simple interface and then telling the user of your library, like, hey, you're going to have to implement this, let's say in Swift, and pass it in on initialization. And it's just a much easier path, and certainly consider it. Like, don't always go Cinterop first. This is harder to test if you have native code that you actually want to test, because then you can't just run Kotlin's build. You have to then output something that you can then bootstrap from, like, say, Xcode, and then call it from Xcode by passing in that implementation. But in the case of, analytics, like, I don't want to nor have any way of testing Firebase that the message actually got there. So we don't care about that at all, right? So just something to keep in mind. And this pass in the implementation is a little more for apps. We do this extensively with our production apps. We just, on app init, we just pass in functions and interfaces and all this stuff just to avoid Cinterop and all that. Libraries, bear in mind that you're going to be essentially putting the job on the user and then probably having them copy and pasting code. It's not the coolest thing in the world, but still pretty useful. So launch crash reporting library. This is another 2019 slide. I just enjoyed the animation. I have this habit of, at my Kotlin Multiplatform library talks, launching a library at the talk. So we launched a crash reporting library called Crash Chaos at that talk, which allows you to symbolicate iOS crash reports from Kotlin. Today we are launching Kermit 1.0-ish. I would say ish because your talk has a definitive date. Your library release, not necessarily. So we're in RC stage. I would say give us weekend next week to get a little further along. It's a logging library, and if you've been watching me talk at all for the last few years, my last talk, I basically said don't build any logging libraries because there's a ton of them, and there's plenty of other places that Kotlin multi-platform needs attention. And I just figured there's a bunch. You got to love one of them, right? And then we started looking around, and I found significant issues with many of them that we really evaluated, and there was nothing I really loved. So without calling anybody out, a few of them, when you configured the logger, it would all be in thread local. This is all related to the concurrency model. And that's fine, except that you configure it in the main thread and that works. And then your other threads are not configured because it's thread local. So maybe you get logging that goes nowhere, right? There's multiple libraries that do that. And I had people argue with me why it's okay, which it is absolutely not. And then the other ones use atomic reference to do mutable config, which means every logging call is going to go through maybe multiple layers of atomic references and stuff. So didn't love it. So we also had 2020, the thing that happened, meant that we had suddenly a few extra sets of hands available to work on stuff rather than client projects. And we also wanted to, I would say the knowledge of building Kotlin multi-platform libraries was a little contained within the smaller group. So we wanted to expand that out. And as a team, we decided to build Kermit, the logging library. And our plan was to, get that out, get some feedback, and do like a 1.0 down the road. And then we all got super, super busy, and that 1.0 like never happened. But now we finally, the very recent time, put some real focus in to incorporate community feedback and do a 1.0. So the 2020 version was non-mutable config, non-global logging. Those are actually related, but I won't go into it. Lambda logging, where you give a lambda rather than a string in the hopes that you wouldn't have to evaluate it. And that was it, and then we never told you that. So now here's our 2021 version. Here's all the stuff that we've added based off community feedback and our own, usage. So global logging, it's as simple as that. Like you just add the dependency, and then in your code you just say logger dot whatever. That's there now, as is mutable config. But it's optional because mutable config on native absolutely means atomics. And if you want to avoid that, you can still do local static config. Added the simple function calls. So if you just don't like the lambda syntax, and even though I understand why it's good, I also just kind of don't dig it all the time. Just call simple functions. Added the platform logger, which I talked about earlier, the convenience function, so that you don't actually have to go out and create a source set on the different platforms just to initialize your logger. Although in a production app, you almost certainly will, and you'll want to, but that's a different discussion. A minor thing, I didn't like the logger was actually called Kermit. It felt a little odd to have the first person library in there. So we kind of formalized and made more boring and corporate friendly names for these architecture constructs. Finally, another thing that we added, and we'll probably add more modules going forward, but we directly added a module for Crashlytics and for bug snags, so you can get breadcrumbs and manage your, handle crash reports and even your regular crash reports through Kermit in a more user-friendly way than Crash Kaios, which is the thing I launched at the last talk. And although we're not getting rid of Crash Kaios, it actually Kermit, these libraries use Crash Kaios under the hood. It is going to be not what you would call the user-facing recommendation going forward. So not going down the drain, but let's say not talked about much. And then a lot of thought went into performance. And you can kind of get obsessive with this. I kind of did. If you are building your own logging library, it's kind of like whatever you're happy with is acceptable performance. If you're producing a public open source logging library, I would say anything you do that is unnecessary is going to be highlighted. So one of the reasonable criticisms we had was like, the Lambda is great, but you had to make 4 function calls to figure out whether or not you were going to need to evaluate the Lambda. So we did a lot of under the hood changes. So, a logging statement should need a quick check and then be, taken out of the running for bothering. And then we very recently, like last week, went further and added my first compiler plugin called Chisel. And what Chisel does is actually quite simple. Let's say that these are your logging levels, and you decide that for our production app, we want only warn level and higher to be logged at all. And you just tell that to Chisel, and in IR, it'll quite literally strip out the logging call entirely, which should avoid, the Lambda being there. It should avoid all the binary you're going to add. And it's kind of the ultimate in performance, as in you don't have to do anything. And you can get rid of your logging entirely if that's what you want to do. That's brand new. Take a look at it. It's obviously IR only. So if you have classic compilers or whatever, it's not really going to work. But that's that. So Kermit, take a look. Again, that's RC2, hopefully RC3 this weekend, next week, and then RL10, especially I want to get some more feedback about finalizing the API. Big team effort. I want to give a shout out to the Touch Labbers, of course, and then some familiar community faces. Thank you very much for the feedback, and go take a look. And if you leave feedback and get no response, that's Michael. He is primary maintainer, and you can bug him or bug me, and I'll bug him, and he'll get back to you. So the soft pitch is, you might pick a different logging library, but I don't want you to have any good reason to pick a different one. So Kermit, why not? There you go. There's the marketing. Another thing I intended to have for this talk, and I was actually thwarted mostly by Gradle and the Shadow plugin than by anything else. And we're not going to call it CPAC. I have a weird naming sense of humor. It'll be something else. But essentially what this does is going back to our classic diagram here of the problem, which is you can point at a header, and then it'll be imported by Cinterop, and you'll be able to access it from Kotlin. No problem. It's actually pretty straightforward. But being able to take that C file and being able to run your test against it, or being able to build every platform and distribute with your klib with the appropriate platform toolchains and all that kind of stuff is actually not a very easy problem to solve, far from it. And you might be able to drag it into Xcode and do it that way, but then that sucks, right? Like this, now that you're explaining to your user to drag into Xcode. Not good. What CPAC essentially intends to do is you'll be able to point at some C, C++, and eventually Objective-C, and maybe even Objective-C compatible Swift. And then this Gradle plugin will then take that, make the LLVM bitcode representation, stuff that directly into your klib. So when you run tests, or if you include the library and the downstream thing, you won't need to know or configure anything. It will just include that binary. There might be something out there that does this that I'm not aware of. We actually yanked out code from Kotlin Native's open source compile a Kotlin repo. And there's a lot of spaghetti, and this is some intricate configuration, but works quite well. So hopefully it'll be out soon. That will help with the testing problem that we had with Crashlytics discussed earlier. So we're going to have another module that is the Crashlytics test. So if you have your thing and you want to run tests, it'll just have stubs that don't do anything, but at least allow it to compile and call without falling over. And then a lot of these slides were today. Like I've been writing stuff today, and I had this realization of like, well, that's great. We can do CPAC for that. Like, can we get something that just looks at the header and generates the stubs automatically so you can have them for testing? And then I realized there probably is a ton of that out in the C world. So to be continued, but we'll see. All right, we're in the random thoughts phase of the talk. You will need to understand hierarchical source sets if you're going to build libraries for sure. When you're going to build a library for native, like you'll define a whole bunch of architectures, right? These are like 2, but if you got to do all of Darwin, it's a ton, and they're all basically the same thing to you as the reader, but at a binary level, they're not. Right? And you're going to want to have a shared source set that is iOS. And going down, it's fine. But if you want to reference something in your shared source set that exists at all these targets that used to not be a thing, and used to have a separate config for IntelliJ versus actually Gradle. That's no longer the case. It's been not the case for a while, but hierarchical source sets didn't work well for complex layered setups. They do now, especially as 1.5.3.1. If you release a library without that now, I think people are going to be upset. So please take a look. Brings up a good time to talk a bit about this, which is KMM or KMP. And obviously, a lot of people assume the killer app for KMP is really native mobile, right? And that's what KMP is. If you're not aware, it's nothing different. It's just kind of a designation rather than a real separate thing, except for the Android Studio plugin, of course. Keep that in mind. It becomes much simpler if you're only going to target those 2 course things, native mobile, right? Like this is Kermit, and although taking out non-KMM targets doesn't reduce the number very much, it definitely reduces the divergence of different things, right? Because native mobile they're very similar things. I mean, Android, iOS to a user, they're totally different, but under the hood, almost the same, right? You know, files, concurrency, whatever, all that stuff's kind of the same. So it is, I think there's going to be a lot more of these KMM specific libraries coming out to facilitate that build. But I would say be very clear when you're doing that, because the non-mobile folks have an emotion I would best describe as stepchild when you leave them out. So just let them know that it's very much not for them. Sorry. And then finally, some notes about the memory model. Again, it's in preview. At runtime, you can query and you can find out if you need a memory model. This was from Stately. I added that a few weeks ago. And then reading the docs today, apparently this exists. You don't even need the Stately thing, although I would say this looks a little less permanent. But there's not much else that we know yet as far as what you're doing from a library developer's perspective or what you can do. And sort of open questions, right? If you build a library that needs a new memory model, is there any way to tell the compiler to not compile with the old memory model or to fail if you do? Like currently, not really. What happens with concurrency primitives? So Java has synchronized and volatile, is there going to be that synchronized in native? And I'm not sure LLVM has the same concept as volatile in the same way. So that's left to be, I don't know so much as defined as communicated as time goes on. We've been talking with Jetbrains a bit. We'll see what comes out. Can you disable freezing? Can you unfreeze? Like, no, probably not. Like, but there's things to figure out. We're all going to learn, but again, come Java to Kotlin 1.7 and further on down the road, like there probably won't be libraries that are freezing, and there probably won't be apps that are freezing. So this won't become an issue, but there will be a transition period, and these things will have to be sort of figured out. But again, personal message, please go test it, because if we don't get some testing, if we don't get some feedback on bugs, it's not coming. It's going to come sooner. The sooner we get that stuff out there, right? And very specifically to get you to go do that. As of today, Kotlin 1.6.0 and 1, add that to your thing. The Kotlin native memory model flag, and then if you're using it also just FYI, Maven central to your plugin repos, because it's not in the Gradle thing yet. In Kermit, I did this. That's where we define Kotlin, and I added to the build script regular build, and then 1.6 without the memory model for a baseline, and 1.6 with the memory model for a baseline, or for a difference. And there's bugs, which I have yet to try to look at or figure out or submit, but they definitely exist. So it's a good way to go and check that out. And yeah, again, don't forget Maven Central. I also learned today that 1.6.0 includes compiling 2 windows from Mac, which makes library development significantly easier, unless you have a Windows problem, in which case you're still going to have to figure that out. I'm going to speed up real fast here because we're already over time, but publishing and CI, this used to be a whole section of the old talk. It's basically one slide now because bin tray went away. Nothing else is really usable in public in any meaningful way. So you publish in Maven Central, and GitHub Actions, although not the only option, is, I think, rapidly becoming the default for all the open source stuff that I've been in touch with, and a bunch of the private stuff too. Sonatype, that's where you do the Maven publishing. Interesting stuff. Go check that out. GitHub Actions, mostly great. They are slow to uptake new versions of Xcode. So even now, if you try to build 1.6.0, it will fail if you need Xcode 12.5, which is old. The current one's 13. So it's not unusable, but just be aware that you're going to have to deal with that. All right, take a breath, goes real fast, and then we're going to go real fast and come in for a landing here. Because we're out of stuff. I don't know, just going through memory lane, big blockers in 2019, compiler plugins, yada, yada. That stuff's changed dramatically. So there's a whole class of libraries that we really couldn't make before, mocking, etc. That's going to come. If you want to put any, you want to be the hero, go figure out mocking for sure. Institutional libraries, back in 2019, this stuff is all missing. Got Kotlin, text time, OKIO, locale, still real difficult to do across all those platforms, but KMM specific, maybe you want to look at that. It's something that's pretty straightforward. What to work on, sorry, I was gonna have a whole section completely ran out of time, so I can't tell you what to work on, but I will tell you now, legitimately maybe skip log. And not just because Kermit, and not just because there's other libraries out there, but then Timber finally is getting a multi-platform treatment, and I'm soft committed to helping Jake do that on native. So instead of working on 0 logging libraries, I'll actually probably work on 2. Anyway, logging is probably covered now, so you can probably skip that now for real. Getting started, whole section planned, and I ran out of time. Join the Slack. Let's talk. Just ping me there, ask me questions, because otherwise I'd say check out examples. Kermit's a good one. It's got everything. Publishing, many targets, see Interop, all of it. And abruptly, that's it. Thank you for coming to my talk. And of course, we are absolutely hiring. Come make cool KMM stuff. That's it. We can unmute if anyone's got wild questions. Let me turn off this sharing thing. Hey. No. How do we do this? There we go.
It's available to everyone to unmute at this time. If you have any questions, we did have a few as we were going. Can iOS side use coroutines and flow if I use them in the common module? If yes, how? If not, what are the options?
Yeah, this gets into the concurrency model stuff. Absolutely, you can use coroutines and flow. There has been for a few years now 2 branches that are published, which is the branch we won't talk about, which was kind of the main one, which didn't let you cross threads, which seems odd, but not really. And then there is the multi-threaded coroutines one, which works more like how you'd expect. And then you just code your coroutines and flow in your common code. And then you still need to have an adapter layer. And we've been writing that manually. So just in the iOS source set, we'll for a suspend function, we write a simple callback, and that's just a one-time callback. And for a flow, you have a callback that might get called multiple times, and you also have to send errors and do other stuff. That's been manual. The Jetbrains team added automatically generated interfaces for suspend functions, but we don't use them because you don't really have access to the lifecycle, so you can't like cancel. It's odd, and I didn't really understand why they did it. I understand ease of use, but it's actually difficult. So one of the things Russell and Skull's was going to work on, but there's actually, we're researching some other community efforts to automatically generate those interfaces to make it easier to use. That's the long answer. The short answer is, yeah, use the multi-threaded version. You might have to write the adapter, and then when the new memory model is stable, all these problems kind of, these weirdnesses go away. But that's going to be a while. What else we got? Okay. Well, I guess that's it. It's hard to tell without the feedback. All right, everybody. I guess. Bye.